I'm now here to introduce our next speaker, Dr. Francisco Galvis, CTO and co-founder at ResiQuant, a Stanford PhD in structural engineering. Francisco specializes in understanding structural behavior and designing solutions that integrate automation with engineering principles. His current focus is on developing technology to support informed decision-making for structures exposed to natural disasters. Francisco, it's great to see you. His keynote is titled AI-Powered Property Intelligence for Insurers via Maps Analysis and Structural Engineering Domain Expertise. Take it away.
Thank you so much, Ash. Very excited to be here. I'm really here because of this problem that some buildings survive disasters while others, unfortunately, do not. The reason why this happened are actually very clear to structural engineers, but not to everyone else. Because of this, my co-founder Omar and I started ResiQuant. We're committed to filling in this knowledge gap and also create the incentives that can help make communities more resilient to any natural disaster. This vision has recently been backed by LDV as our lead seed investor, and I'm very excited to share more details of what we're building here with you today. So let me take you back to the aftermath of Hurricane Ian in 2022, specifically to Fort Myers Beach in Florida. When I visited the area, I saw that buildings that were not next to each other had dramatically different outcomes. And as a structural engineer, I look for visual cues that can, interpret with the proper construction practices in the area and history of building code regulations, explain why this outcome happened. And we can do this before the event happens and before hurricanes, earthquakes, wildfires, tornadoes, any natural disaster. Unfortunately, key decision makers in the built world don't have the luxury of a structural engineer by their side sharing these insights at critical moments. And that's stressing everybody out, but especially the $200 billion insurance industry that's absorbing this risk. So what this effectively means is that the insurance industry in general is flying blind in this new era of rising risk. And the only thing they can do is really make really radical decisions, like pulling completely out of markets like you've seen in the past couple of years. But the future doesn't have to continue this way. Insurance companies can continue to do business in high hazard areas if they have the proper engineering insights that can help them underwrite confidently in these areas. And that's what we're doing at ResiQuant. We are basically creating multi-model AI agents that can give any underwriter a structural engineering X-ray vision. So let me walk you through a couple examples in the context of earthquake insurance that demonstrate how this technology works and it's transforming the industry. The first example is this building located in Southern California, that L-shaped building, very architecturally interesting. The broker who represents the property owner, submits a set of documents to the insurance company stating that this building is a 3-story office building made of masonry non-combustible materials. Right? That's helpful for fire rating, but not only for earthquakes. So an underwriter, if they have time, will look at this building and try to see if it's really masonry and will probably agree. You see the brick right there. When they deploy ResiQuant's engineer AI agent on this building, there's a few things that come up. The first is that the building has a severe plan irregularity. And remember that L shape we just talked about. Has continuous windows, and it has large open spaces to accommodate the office occupancy. Those 3 things make it really hard for a structural engineer to make a masonry system work for this building. If you then consider that at the time, this building was designed with the 1982 Uniform Building Code, which favors steel construction for regular buildings, can start look for the visual cues for a steel frame building. And that's exactly what this building is. This building is not masonry. It's a steel moment frame, which behaves a lot better than a masonry building, which is vulnerable to this kind of outcome. What this means for the insurance company is that they can put a much competitive offer for this risk, and for the property owner that they can get covered with a lot less cost than they will otherwise have to pay. Second example is this 2-story single-family residential wood frame building. Not really much to debate there, but when you deploy ResiQuant's engineer AI agent on this building, you realize that it was designed under the 1943 Uniform Building Code, and that it has a crawl space, that area at the bottom of the building that's highlighted in the image. That crawl space under that building code did not have to be laterally braced for earthquake. What that creates is a significant structural vulnerability known as cripple wall that can have this outcome. When with this insight, the property owner will be incentivized or will know that, that they can do some retrofit is actually very inexpensive and become eligible for a sizable reduction in their earthquake insurance. That's how resilience is incentivized. This technology has already been deployed in two of the largest earthquake insurance in the country, Palomar and Golden Bear, and their underwriters are turning unknowns into knowns as we speak. In the past 3 months, we have already processed 10,000 submissions and analyzed more than 100,000 buildings in their book of business with this type of technology, and we have exciting announcements coming up that will also support wind and wildfire exposed properties. The next 10 years, we envision that insurance companies using this technology won't have to pull out of markets. They can stay and do business there. Real estate developers and property owners would have the incentives to retrofit existing buildings or build resilient big buildings from the get-go. And that is how communities will bounce back in just a matter of days after any natural hazard events instead of years. Thank you so much.